Hello everyone, and welcome to the 8A.2 video, which is regarding the long division of polynomials. And this is especially going to come into play not only in this chapter, but when we get to graphing rational function, we're going to be using the long division to help determine what asymptotes, vertical, horizontal, slant. So this skill is being taught now, but will be used quite a few times throughout the semester. So please keep the details in mind as we're going through today. So first, we have a bunch of vocabulary, which will make more sense as we go. We have something called a dividend, which is the number or polynomial that is being divided into. We have the divisor, is the number or polynomial that is being divided by, that one is doing the work. We have the quotient, which is the answer to a division problem. And we have the remainder, which is the amount that is left over. And so to understand these terms, what I think is good to do first is to long divide by hand before we get into anything with polynomials. And this is a good skill to have because I know you have your calculator to do it more quickly, but this is important in order to help understand the long division. And so the first thing we do is ask ourselves, how many times does 17 go into 5? Well, it doesn't divide in evenly. So we expand and we say, how many times does 17 go into 53? And so the first thing we think about when we are long dividing is how many times does this number divide into this one, which makes sense based on long division. 17 goes into 53 3 times, and 17 times 3 is 51. So what we do next is we then multiply, so we divide, and then we multiply the 17 times 3, which is the 51, and we put it directly underneath the 53. What we need to do to keep going is then subtract. So then 53 minus 51 gives me 2. 17 doesn't go into 2, but if I bring down the other 2, then we can keep going with this process. And so pretty much what we're going to be doing with long division throughout this video is first dividing, then multiplying back, subtracting, and then bringing down. So if we continue the process again, 17 goes into 22, or divide. So I'm going to write divide or think about saying goes in. It goes in one time. So I put a 1 up here. I then would multiply the 1 times 17 to get 17. I would then subtract these and end up with 5. 17 doesn't go into or divide into 5, but if I bring down the 8, it does divide into 58 somehow. 17 divides into 58, or 17 times 3 would again be 51, and that's the closest we can get to 58. So we put another 3, multiply 17 times 3 to get me 51. We then subtract these numbers and get 7. 17 does not go into 7, but if I bring down the 1, it could go into 71 a certain number of times. So to figure out those number of times, I'm going to do some multiplication over here. 17 times 3 was 51. 17 times 4, 28, is 68. 17 times 5 is 85. So it looks like 68 is the closest thing. So then this would be a 68. Let me rewrite that. That is very not neat there. So if I then had my 71, I would subtract the 68 because I multiplied 4 times 17, got 68, subtracted, and got 3 here. Okay, so now we're at the end of our number. So we're going to put a decimal point here. So after this place, we're going to start having the remainder because there's no more numbers to bring down. So when that happens, we bring down a 0. So now the remainder starts. 17 goes into 30 one time. And if I subtract off 17, that would be a difference of 13. 17 does not go into 13, but again, if I bring down another 0, 17 does go into 130, I know, 7 times. And we can continue this process. This decimal does not repeat and does not end, so we can keep going and going and going. But just to bring back to the vocabulary earlier, now that we've done this example, my dividend, or the number that's being divided into, is the 53,281. My divisor doing the work is the 17. The quotient is the answer to the division problem, not the remainder, would be 3,134. And the remainder is the 0.17 on and on and on. Now, something you need to know is how we write remainders in this course is not as 0.17 repeating. We write it as a fraction. We write it as what's left over, which is the 0.17, over what I started with, the 17. So in this example, we would say that the remainder is the 0.17, and I will keep going so you know what it is, 0.17647, on and on, over my divisor. And this will make more sense as we keep going. Okay. The next example says find the zeros in the polynomial. And this one, if you look at it, you might notice it's a quadratic that is factorable. So if I want to find the zeros, that would be x times x, 3 times 2, minus minus to get the negative 5. So my zeros would be x equals 3 and x equals 2, or 3, 0 and 2, 0. Now, you might be wondering, why is this example in this video? We're going to be doing this example in a little bit with long division, and I'm going to show you that you're going to get the same answers that you would if you would have factored it. So just keep that in mind. This division algorithm is what I was just talking about above, this idea of how we write our final answers with a division. So I want to show you where the division algorithm comes from. So this is what the original algorithm is, but to get from here to here, because d of x represents my divisor, if I take my original function, d of x times the quotient plus the remainder, and I divide every single term by the divisor, which makes sense based on the name, these would cross out, and I'd left with f of x over d of x equals the quotient plus the remainder over the divisor. So when you're writing an answer to a division problem, you would have your quotient, which was in the previous example, the 553,281, and then you would write it as plus the remainder over the divisor. So if I go back to that example, if I was going to be official about it, your answer would be 53,281 plus 0.17647 on over the divisor. And this idea is going to come back and help us very soon. So let's get to it. Let's divide polynomials. Okay? So my goal is to divide x minus 2 into x squared minus 5x plus 6. What we want to do is follow the same idea as the previous example. We would like to divide first, then we would like to multiply back, then we want to subtract, and then we want to bring down. And this example is the same example as the factoring one. So we know these should be our answers. So let's see what happens here. So to start this problem, what we would do is ask how many times does x go into x squared, or we'd think division. X squared divided by x gives me x. So I'm going to write my x over the like term, and then I'm going to multiply back. X times x gives me x squared, and I'm going to line that up. X times negative 2 gives me negative 2x. And next we're going to subtract like we did on the previous example. But I'm going to subtract an entire quantity. And when I do that, my original sign was positive, but it becomes a negative here, and this becomes a positive. So then if I combine or bring down, if I have x squared minus x squared, those cancel out. Negative 5x plus 2 is a negative 3x, bring down plus 6. Then we'd start the process over. How many times does x go into negative 3x, or division? Negative 3x divided by x. So that would be negative 3x divided by x is negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. Now if I subtract, I'm really subtracting an entire quantity. And when I do that, both of my signs change. So this becomes a plus, and this becomes a minus. And if I do that in a different color, this becomes a plus, this becomes a minus. Negative 3 plus 3 cancels. Minus 6 cancels, so I'm end up with 0. So my remainder is 0. So my answer would look like this. Would be x minus 3 is my quotient plus 0 over x minus 2. Now, we don't technically need to write this when we have a 0 remainder, so my answer would really just be x minus 3, but it's just good for the practice. Now notice, if I think division, when I divided this polynomial by x minus 2, my answer was x minus 3, which is the same as if we look back at this problem here. So if I try the problem again, a different one. If I'm going to take x squared plus 2, and I'm going to divide that into x cubed, now notice this, don't forget the placeholder. Notice that we're missing an x term. So we'd write plus x squared plus 0x minus 3. We need that as the placeholder. How many times does x squared go into x cubed? Well, it goes in one time, just x. So I'm going to write my x over the like term. Now I'm going to multiply back. X times x squared is x cubed. X times 2 is 2x. Now, because I'm subtracting everything, my signs change. This really becomes a negative, and this also becomes a negative. So when I combine down, these cross out. I'm left with x squared. If I bring it down, 0 minus 2x is negative 2x, and bring down the negative 3. Now I start the process again. X squared goes into x squared one time. So I'd write plus 1 up here. Now I multiply backwards. We get 1 times x squared, and then 2 times 1. Because I'm subtracting, both of my signs change from positives to negatives. So these cross out. I'm left with negative 2x minus 5. So now x squared does not divide into negative 2x, because if I tried negative 2x divided by x squared, this power is bigger, so that doesn't work, which means that now this is my remainder. So my answer, my quotient would be x plus 1, but then I'd write plus the remainder, negative 2x minus 5, over my divisor, x squared plus 2. So this would be my answer to the second example. This is my actual quotient, and this is my remainder. So something good to point out here is that x squared plus 2 is not a factor of x cubed plus x squared minus 3 because there's a remainder. But on the previous example, x minus 2 is a factor of x squared minus 5x plus 6 because there is no remainder. And that'll come up again and again. Let's tackle this last example. We want to divide x squared minus 3 into x to the fourth plus 3x cubed. We need a placeholder of 0x squared plus x minus 2. So if I think how many times does x squared divide into x to the fourth? X to the fourth divided by x squared is x squared. Now if I multiply back, x squared times x squared is x to the fourth. X squared times negative 3 is negative x squared, negative 3x squared. When I subtract, my signs change. This becomes a negative and that becomes a positive. So if I combine down and bring down, I'd have 3x to the third plus 3x squared plus x minus 2. Now if I multiply x squared into 3x cubed, if I'm taking 3x cubed and dividing it by x squared, I'm left with 3x. So now if I multiply back, 3x times x squared is 3x cubed. 3x times negative 3 is negative 9x. If I combine down and subtract, both of these signs change. So I'm left with 3x squared plus 10x minus 2. I can keep going again. X squared does divide into 3x squared 3 times. So if I multiply 3 times x squared, I get 3x squared. 3 times negative 3 is negative 9. Again, my signs are going to change. Minus plus 10x plus 7. X squared does not go into 10x, so this is a remainder. So my answer is x squared plus 3x plus 3 plus 10x plus 7 over the divisor.